Here are some definitions for atoms versus ions. You should be looking in this page of your unit packet to fill in these notes. Definition for an atom. Elements off the periodic table that are written without a charge. Some examples would include the following. Sodium. Don't know why that changed colors. Chlorine. Tungsten. Gold. Notice none of these have a plus or minus charge. Sulfur. These are all atoms. Ions, atoms that have lost or gained electrons and now have a charge. Remember that if an atom has lost or gained electrons, it's considered an ion. For instance, magnesium 2+, sodium 1+, sulfur 2-. We also have something called polyatomic ions, which we're going to talk about in a moment. That would be something like SO4 2-, that's a sulfate, or OH 1-, or NH4 1+. So anything that has lost or gained electrons, an atom or group of atoms that have lost or gained electrons, is considered an ion. We got magnesium with a plus, and you can write your charge. You will often, the proper way is the number, then the plus or minus. But sometimes you may see it written with the plus or minus and then the number. That's okay. This is the proper method, number then symbol, plus or minus symbol, but either way is acceptable. Okay, so monatomic ion, a mono means one, ions form from a single atom. So these are all monatomic ions because they come from a single atom. How do I know they're a single atom? Remember that an atom on the periodic table starts with a capital letter. Some atoms on the periodic table have a capital and a lowercase. So anytime you have a single capital letter, you have an atom. So this is sodium ion, magnesium ion, nitrogen ion, and sulfur ion. Be sure you're getting your definitions into your notes. Polyatomic, poly means two or more. Ions form from two or more atoms. So here we have two atoms, oxygen and hydrogen with a charge, sulfur and oxygens with a charge, phosphorus and oxygens with a charge. We have carbon, hydrogens, and oxygens with a charge, nitrogen and hydrogen with a charge, hydrogen and oxygen with a charge. So all of these are polyatomic ions versus monatomic ions because they come from two or more atoms acting as a unit. Then we have cations, positively charged positively charged ions. We have a cat with plus i's, that's the trick to remember. So this is a polyatomic, two or more atoms, cation. And this is a polyatomic, two or more atoms, ion. And this is a monatomic cation and a monatomic cation. All four are charged positively, making them cations. These two have two or more atoms, making them poly. These two have one atom, making them mono. An anion, this is a negatively charged ion, almost looks like the word onion, right? Almost looks like the word onion, okay? So you can think of onions being a negative smell on someone's breath, just as a trick to help you remember. So negatively charged ions are considered anions. So these first four here are polyatomic anions, two atoms, two atoms, two atoms, three atoms, so two or more atoms are polyatomic. They are all negative, so they're anions. These two are monatomic anions because they're negatively charged but only come from a single atom. So on your periodic table, at the top of your periodic table, if you flip it over to the back side, I'll call that the ion sheet. You will have your anions at the top, looking something like this. And you will have, notice that all of those, if you look at their names, all of them end in either "ide," "ate," or "ite." So if you're looking at a name of a compound and ends in "ide," "ate," or "ite," you most likely will find it up here in this list. Also, the bottom part of your ion sheet, you will see positively charged. Some negatives over here, but we're really wanting to focus on the positively charged ions here, okay? And the back of your periodic table has a lot more filled in than this one does on the screen, but it looks very similar to this. So what I want to introduce to you is the concept of having a roommate or not having a roommate, and what that means for us to help us through this. If you notice that lithium and beryllium, sodium, magnesium, potassium, calcium, all these guys only have one possible positive charge. We actually call that the oxidation state. We won't use that term very often though, but the oxidation state of the positive charge. Okay, they all have a single roommate. If you think of each box as a house or an apartment, they all have a single roommate. Even things like zinc and cadmium and silver and aluminum all have one person or one in their box, zinc. The others have multiple people in their box, what I call roommates. So the ones that have roommates, right, have multiple oxidation states or multiple positive charges. Pardon me. Okay, so those are roommates, meaning more people living in their house, more than one, right? 3 roommates, 4 roommates, and so on. And again, your backside of your periodic table will have a lot more of this stuff filled in. It's updated more than this. But then there are some that don't have a roommate. They live alone. And that'll be important in just a moment. So here, this iron has a roommate, right? There's 2 people living in iron's house. We have an iron +2 and an iron +3, or iron 2+ or 3+. You would specify who's who by putting a Roman numeral after the word. So iron 2+, iron 3+. Iron 2+ gets a Roman numeral 2 after it's the word iron, and iron 3+ would get a Roman numeral 3. So if you did something like osmium, okay, osmium, which is right here, you're going to have probably a 6+, so osmium 6+, osmium 8+. Okay, so that's going to be osmium 6, Roman numeral 6, and osmium 8. So the value of the Roman numeral matches up with what the charge is of the roommate. Here, potassium lives alone, meaning nobody is there. It only can be a +1 charge. So I would not, could not, would not, should not use Roman numerals in the name of potassium. All right, if you could please turn to your page in your packet that says ions versus atoms. I will show you what that looks like here by going over to the worksheet packet. So you're going to fast forward down through some of these notes. And you're going to get to this worksheet right here. Atoms versus ions. Currently this year it's on page 11 of the packet. That may change year to year, so check around page 11. Okay, you are going to go ahead and get in your packet and turn to the page that says atoms versus ions. You'll need a periodic table out at the same time, and I will ask you to please get into the next video. Thank you.